Okay, in exercise 1, we used the digital write and pin mode and delay functions from the Arduino library to blink an LED that was connected to pin 13 of our Arduino Uno. In this exercise, we want to read a push button switch that's connected to pin 12 of the Arduino. So let's see how to do this. And what we'll do is we'll first wire up the push button switch, and when we're all done with wiring it up, we'll check to see if the button is pushed or not. We'll then write the value of the button to the LED connected to the pin, and then we'll wait for about 1 second and we'll just repeat this. We'll be making use of pin mode, digital write, digital read, and delay functions. Before we get started with the coding portion, let's actually figure out how to wire a push button switch to pin 12 of the Arduino. Here's an example. So here's my Arduino board. Uh, Here is the breadboard that I have. I pushed my push button switch right here across the trench of that breadboard. The top left leg of that push button switch is connected to a high voltage. That's the red wire. Red meaning hot wire or high voltage. And the other feet of that switch goes through this resistor. The resistor is basically a element that opposes the flow of current through it. It makes current. It's basically opposing the flow of the current through it. So we have that leg of the switch connected to one leg of the resistor. The other leg of the resistor is connected through this black wire to ground or 0 volts. At the same time, this green wire is also connected to the leg of the switch, and that goes into pin 12 of the Arduino. This breadboard and this switch is being powered from 5 volt brought in through this red wire from the Arduino and 0 volt ground brought in from the ground pin of that Arduino right there. So this is the circuit diagram that I want to do. Let's first, well, now that we have the picture here, let's find out how does this switch actually work. So here's an example. So here's the switch that I was talking about earlier. In electrical schematics, we draw a switch basically as two blank posts and a push, so basically indicating that if I push on the top, it'll make contact and complete the switch. Here's one way to wire that switch. Here's another way to wire that switch. So let's see what happens if I wire the switch this way. So the Arduino input, so this is the pin 12 of the Arduino. So imagine that I am sitting right there and observing what do I see from the Arduino input. From this way, I see that there is a big hole right here, so I can't quite see 5 volts, which is logic high. But if I look through here, I see a big mountain and I see logic low right there. So when my switch is not pressed, all the Arduino input sees is a logic 0. So that's a path it sees. When I press the switch, the Arduino input basically sees. So if I let me press the switch. So that's where now switch looks like. This gap has been bridged. So to my eyes or the Arduino input that's looking at this particular point, the Arduino input sees the 5 volts, meaning logic high. So when I press the switch, I see high. When I don't press the switch, I see low. Right? In fact, from this switch, I actually have connection both to high and low when the switch is pressed. But current likes to flow through path of the least resistance. So this mountain right here, which is called the resistor, acts as a big path, a harder path for current to go through compared to the straight bridge. Hence, all the current will flow through here, allowing my Arduino pin to see a logic high. Here's another way of configuring the same switch. So this is another way. So let's take a look. If I'm looking at from the Arduino point of view, these are my eyes. I'm looking at what's here. Well, I try to go this way. Well, the bridge is broken and I can't see it's 0, logic low. But I can go this way through the mountains and I can see logic high. So I'm normally at logic high. When I press the switch, I go here, I actually see logic low. So when I press the switch, I can see logic low. I also have a direct connection to 5 volts, but it through a much harder path of this 1 kilo ohm resistor. So because the current likes to flow through the path of least resistance, the Arduino input will become equal to a low. Right? So that's how we have it wired. That's what this one is showing right here. So switch is open, Arduino, that's pin 12 of the Arduino. It's seeing direct connection of, it's seeing 0 volts. Uh, switch becomes closed. It sees 5 volts or a logic high. So this is how we have wired up this particular configuration. So switch is open right now. Switch is open right now. So from this pin, if I look at what value I'm seeing through this resistor into ground. So this black wire is ground or logic low. So that's what I'm seeing when the switch is not pressed. When the switch is pressed, I pressed on this switch. From this switch wire, I come to this point, go through the switch, and then go out here, and I see the logic high. Okay, so that's how it's wired. So this switch is wired up so that when I don't press it, I get a logic low. When I press it, I get a logic high. Okay, now let's move on from the wiring. If we have the wiring all set up, the next thing we need to do is we want to check if the button is pushed or not and store that particular value. And then we'll write that value. In order to store the value, so let's take a look at storing value into something called variables. For now, a variable is basically a place to store a piece of data. There's different types of variable, characters, bytes, int. Today we'll use the int, and there are other variables as well. So let's talk about how do we store a variable. So before doing that, so let's go back here. We're going to make use of 4 different functions again, pin mode. So a quick recap. Pin mode basically takes a particular pin and sets it as either an input or an output. Digital read reads from a particular pin, and what it does is it reads from a particular pin and returns either a high or a low. So if I want to use it, I need to read a pin and store that value into an integer variable. digitalWrite basically writes a particular value, high or low, to a particular pin. And delay, as we saw last time, basically has millisecond delays that we can use. So let's bring up our Arduino IDE. So here's my Arduino. So what I want to do is I have the wiring all set up. So my wiring is all set up. My goal is to read the value from this button and reflect that value on the LED connected to pin 13. So I have two things. I want to read from pin number 12. So I need to set pin mode of 12 as an input because my computer is reading that pin. I want to write that value back into an LED connected to pin 13. So pin mode of 13, pin number 13 should be an output. So that's my setup. That's all I need to do. I've set up my 2 pins. First thing first. So what do I need to do? I need to read I need to read the value of pin number 12. So digital read from pin number 12. When I do this, it'll probe what the switch is doing and come up with a value which I need to store. So let's store it in an integer, int. I'll call it a is equal to digital read. So what this now does is it'll read the pin at pin number 12, see if that pin is high or low, and whatever value it gets back, it will store it temporarily in a variable called A. So A will either be high or a low. So we've read from pin 12. The next thing we want to do is we want to be able to write to pin 12. So digital write. We want to write to pin 13, which has the LED. So 13. What are we writing? We're writing the value that we just read and stored. So we're writing whatever A is. And we said we want to wait for 1 second before we loop back and read this pin again. So let's see what happens here when I get into setup. Pin number 12, which has the switch, is set up as an input. Pin number 13, which has the LED, is set up as an output. In loop, which happens over and over again, I read from pin number 12. Whatever value I read, I temporarily store it into a variable called A. I then take that variable A and write that value to the LED, which is connected to pin 13. I wait for 1 second, and then I go back to the first line and I keep repeating. So let's see what happens here. So here is my setup. I'm going to hit start. Right now my button is not pressed. So since my button is not pressed, I am basically connected to 0 through this resistor, so the LED is not lit up. Let me press that button. When I press that button, I'm now connected through the red wire to high voltage. If I release that button, light goes off. Press the button, light goes on. I release the button, light is off. Press the button, light comes on. Okay. So basically in this exercise, we looked at how to set up a pin as uh, an input. We saw how to set up a pin as an output. We saw how to read and temporarily store that pin into a variable. And we saw how to write that variable to an LED. And then we also use the delay functions again. Okay. So